Welcome everyone to the latest edition of the Reimagine Mobility podcast series. I'm here with Jingtao from TTS. Jingtao, explain a little bit to me, TTS, another three-letter acronym just like AVL that I work for. You guys are in the V2X space. Tell me a little bit what you're doing, what you guys are doing, and also what are we here? We're here in a garage with a cool car in the back, so tell me a little bit about that as well.
Yeah, absolutely. Well, it's a great honor and pleasure to be here with you, Stephan. So it's TTS stands for Traffic Technology Services. Yeah, with the very dry words that we are in the V2X space, as you mentioned. So it's a connected vehicle service company. So we specifically focus on one thing, that's those are the traffic lights. Everybody we drive through those things every day.
Some pay attention, some don't.
Some don't. Yeah. So every so often we wonder, so when this thing will turn from red to green, right? That's our anxiety that we should do. So the TTS started focusing on that. So it's to starting with a pilot with one auto OEM, which I'll mention later. So it's to predict when the traffic signal will change from one state to next and will change again. So what it ended up is in the drivers, exactly like we do see these traffic lights and see what turns out to be an application is a dashboard display when that red will change to green. So 50, 49, all the way down to that. So these are indeed in these production, some of the production vehicles in with our launch customer Audi. And also, since 2016. 2021 was Mercedes.
Okay.
Yeah, we're live in their service production vehicles and mostly in North America.
Okay.
Since last year, we also have our footprint in China, so they're supporting Ford vehicles.
Okay,
yeah,
Ford.
So,
okay.
Yeah. So in that country, and obviously in between, we have Europe as well. So you can imagine with these European makes. So yeah, so that's primarily we got our fame, and people know us for. So this company, and also in between, we work on these very interesting pilot projects, like working with the AVL on this one, as you said. And with the Michigan Tech University leading the project, as we joined the team specifically also to provide the same traffic light data to the team so they can optimize the cohort. So a fleet of vehicles, how to have a central intelligence working with the AVL team to direct this cohort, when to accelerate or when to decelerate so that we can catch a green wave for the whole cohort. And there's a central intelligence that the AVL team has built together with the MTU and other teams to direct the cohort if needed, when to break this cohort into different smaller packs. So there are different packs that go through the green lights as a group. Yeah. Right. So yeah, this is a very interesting. I will just offer the track. So, yeah.
And you're the CTO, correct?
Yeah.
So you want to give credit to that too. You're the CTO. That is very good. So let me ask you something about, I don't know, I have to remember now, maybe 15 years ago when V2X or DSRC first came on the ground, right? The big focus back then was, let's just say in the US at least, signal phase and timing, right?
Yeah.
It sounds very similar to what you guys now have finally, let's say 10 years later, implemented. What technologies do you use? Do you use DSRC? You use wireless for the V2, let's say infrastructure, right? Or does it not matter to you? You are agnostic to the technology. Somebody else does that, but you more provide the rest of the system, so interfacing with the traffic light and the information.
Yeah, that's you covered it all actually.
Okay.
So interesting that you mentioned this DSRC. Indeed, that's right. It's in the DSRC was the starting point with the US DOT was supporting, and with a lot of pilot programs funded by the DOT. And lately, with the cellular V2X, right? These are the communication channels where the data can flow from specifically between the vehicle and the infrastructure.
Point to point instead of a tower.
Right,
exactly.
Yeah. Those are the on-site broadcasting when it comes to V2I, vehicle to infrastructure. So then for TTS, when we started the company, well, I can say one of the co-founding members, we realized this. difficult and expensive to retrofit these traffic lights, to have all these equipments to broadcast this. This will take a long time. And then from our profession of being a traffic engineer by training, we realized, we know that, so the infrastructure are actually networked by themselves. Meaning that we see these traffic lights operating, there's a central system, mostly in most of the world, across the globe, there's a central system that manages these traffic lights or traffic signals in real time. So that's how what we did is we tie our system, we developed the system, the cloud backend, tie our system to this central computer. We certainly work with a technology partner to build the APIs to do that. But then the key point is, once the city allows us to do that connection, then we will get the data in real time all at once, not just the one signal by one signal, but we will get the hundreds of them, thousands of them, if the central system manages them all together. So we'll get them all at once. So then we get all the raw data onto the cloud backend, where we process it, standardize it with all the data science technology and techniques. And then we make it a standardized SPAT, so signal, phase, and timing, where we can send it over through the cellular to the vehicles. Now almost every vehicle is connected. It's connected with the
and GPS, so you know where they are.
So it's also you mentioned that. So it's for different, we have a different delivery mechanisms. So it's for some of the OEMs, like I mentioned, Audi, they have built for 10 years, built a strong backend. They can distribute the SPAT messages to the vehicles on the road with a vehicle GPS. But for some of them, for like Mercedes, so we do know through their portal, we don't know who that is, but we do know this Mercedes vehicle position. We try to match it to the network and try to match it to the service region, to the particular intersection, to a particular approach. So we see that it's a very thin, lightweight data to them. So to reduce the bandwidth and to reduce the transmission. So then the vehicle has exactly the same function as it's if it is receiving the data from the broadcasting. So it's just the beauty or the advantage we would see to see all leveraging existing infrastructure. Communication, the infrastructure itself, and communication, and also down to the vehicle. So the whole data chain is already existing. Our job is connecting the dots to build the application.
Very interesting. So when we jump a little bit to the project you're working on, that AVL is part of it as well, and as like you mentioned, Michigan Technical University and many other ones. What are some of the main achievements that you feel like the team has achieved with your technology, maybe specific?
We achieved a lot. I really feel very honored to be part of this team. In fact, TTS was introduced to the team by AVL. So as I mentioned, I was in AVL office, and then we supported some of your earlier tasks with the PREM, so predictive energy management. So that's how we the two teams, AVL and the TTS, began to work together. Then when this project, or when this the opportunity came up, so the AVL team introduced us to the whole bigger team. So that's how we started. And then at the beginning, we also have the same notion. The team has the same notion. Oh, we have to build a DRSRC unit, or have to do all that. So it turns out we don't. We don't. So everything is already on the back end. Whenever you make the web request,
so really, you, if I may interject, you really found a way of implementing this that 15 years ago nobody thought about. Because 15 years ago, right, we thought about, oh my gosh, every single intersection has to have, is sometimes from a different manufacturing, needs a different interface, needs a specific DSC unit to communicate, lots of money, lots of cost, lots of time. Your brilliant way found a way around and really made it possible to do, as you have shown with Ford now, with Mercedes, with Audi. So that's it's cool.
It's I guess essentially, so we are from that traffic engineering world. We know this communication. So for all these years, we have built we have onboarded over 50 metro areas. So over 25,000 signalized intersections. That's some scale.
In the U.S.?
In the U.S.
In the U.S.,
In the U.S., So it's, so that's the way we go. And then for this project, what we feel we achieved a lot is not just the HMI functions, right? You give, the countdown timer and the green speed advisory give you the comfort how you want to drive through these traffic signals. But essentially what really excites us and working with the AVL and the team is how to get the data into the vehicle to do the powertrain automation.
Optimization, right?
Yeah, the optimization.
Yeah.
Obviously, we had done this individual vehicle optimization, but this project's about the cohort, how to direct the whole fleet to all cooperate with each other. So that's this technical achievement is I think is a huge.
Okay.
For us, it's also fun to work with the team. So to scratch the surface, you feel so well of the automotive engineering world.
Sure.
It's quite
it's a different world, right? But when two different worlds come together, great things can happen, as we're showing here, I think. Right? Again, traffic control, maybe many people don't think about. Sometimes maybe now I should know who to call and say that light doesn't turn green. Can you please make it turn green, right? But it's interesting. So maybe a technical question for you. Let's say there's a mile-long stretch before I hit a light. How soon as I hit on that mile-long stretch before I hit the light, do I know, am I going to get a green wave or not? Is it telling me early? Is it waiting till like I'm a half a mile or a quarter mile away? Well, what does it do? What does your system do?
So it feels like we're back to the engineering discussions now. So, with this cellular communication, we're not bounded by the physical limits of these on-site broadcasting, be it a C-V2X or DSRC. So whenever the data is always there. So whenever there's a cellular connection, the vehicle or the application should know where I am, where the data, how the data would look like, or rather when the signal will change.
Sure.
As in our backend, we have additional specifications how when the signal will change. We call it a prediction horizon. That's exactly tied to if you're a mile away from the stoplight. You will be able to have this prediction horizon, meaning that you have 2 minutes or a few minutes when the signal will change in the next 2 minutes and change again to give you enough time for the driver ourselves, or the machine to understand when I should plan to do the stop, or when I should plan to do the
coast down,
to hit the next. It may be not the current green window, but the next green window. So this is important. What you touched on is this we call it prediction horizons. Is this long forecast time that give you enough time to plan ahead.
Sure.
So my point is, the case that you mentioned is already covered in this application.
So that's the E-horizon, right?
This E-horizon.
Okay. So for you as a CTO, what's the most fun part working on, let's say, this project or working with the automotive space, right? I mean, you said you're coming from a different industry, you're tied to the automotive space, but you're the guy that everybody makes stop when we drive. When we have fun driving, you make a stop, right? Again. What is fun for you to do in these types of projects?
I may want to quote some of the engineers from the state DOTs. He's also a traffic engineer, so chief traffic engineer from Indiana DOT actually. So he's quoting his words is, in the past 100 years, we rely on our eyes to make the stop, so to stop and to go in front of the traffic lights. And these two worlds, infrastructure world and the automotive engineering world, are very much apart. There's not really a touch of these two worlds, except for the traffic signals, we have the detection, right? So, but it doesn't tell who that is. Only when ourselves touch that loop. Or it's same by the camera.
Like somebody is there, but you don't know
who that is. So this is very much the only touch point between the two worlds. But then now with this connected vehicle, we know who this truck is, meaning that we don't really know the driver, but we know who that truck is, how far it is from the stop line, at its speed, instantaneous speed. Then we could customize this for that particular vehicle or for the whole cohort, as we have proven in this project. So that's when we see the connected vehicle world. We begin to see these two, the automotive engineering and the civil engineering, begin to merge, to work together. We would see this is only the start.
Okay.
And also on this project, we have not only serve or work with the cohort fleet, we have been sourcing data from a third-party connected vehicle data company. They provide the GPS traces for over 10 million vehicles in the States.
Okay.
So we stream their data in every day. It's a lot of data. So it's so about 14 billion data points. Yeah, maybe I'll need a correct on that one. So it's and then we focus on these few intersections in the under test. So to get the queuing data out as well. So this is the two pieces. So as you mentioned, so our individual vehicle coming to the stop line, but we don't know when this if there's there are vehicles stopping in front of us. So this, out of this project, so we derived the algorithm to decide to profile the vehicle queuing. So how many vehicles are in front of me? So this cohort can plan a little better, saying that you're not going to hit this green, but instead you want to join the end of the queue.
Right.
So that queue will influence your speed as well. So we'll try to give that data as well and on top of the SPAT together to the cohort.
Okay, interesting.
Yeah.
From my perspective, there's so many possibilities with this technology tied together with let's say, autonomous driving or semi-autonomous driving. Are most of your customers looking at, we want to reduce congestion, we want to make it easier for my vehicle owner, Audi, let's say, we want to make it easier so that they have a smoother ride? Is it not the smooth ride? Is it the fuel consumption that they want to improve? Is it the from a pollution standpoint in a downtown city, they want to be better predicting that you can drive and manage the traffic by this? Is it a combination of it? Does it depend who it is? It may be one or the other. Or what is the main driver or the technology or the benefits people want out of when you talk to your customers?
We have two sides, especially for this vehicle to infrastructure. We have two sides. On the infrastructure side, why should the city work with us? Why should the city give out the data? It takes some efforts. Then on that side, exactly as you mentioned, they care about their citizens or safety. Safety is the number one.
Big one. Okay.
And that's a big one. So Vision Zero has been there being everywhere. And then certainly the reduce pollution and the congestion. That's also important. Mobility side.
Sure.
So that's their concern. So for us, and on the client side, customer auto OEM side, the tier one side, and then it's the same goal. We want our drivers to have the best fuel economy and to have the least anxiety when driving on the urban roads, and not to have the accidents. Yeah. So these TTS or our company is right in the middle. So on the infrastructure side, we do provide the data feedback to the safety engineers, meaning like what we have seen in the project. So what are the queue there, the typical, and what are the number of stops? So what intersection has the highest number of stops in terms of So, and these are the information that city usually would want to have. And in the past, they would send the people to the field to verify if that's the case.
But now it's a feedback loop.
That's a feedback loop.
Interesting.
Interesting. So that's what they see that. But certainly the safety is the number one.
Number one
case. We're still working on that, trying to provide a coherent experience to cover both the safety and the mobility applications. So,
interesting. Yeah. Maybe last question. I'm sure there's a lot of R&D or additional R&D activities and developments coming out of this project. So maybe share a couple of points on that. And then the other thing is, in your opinion, is your technology ultimately going to be more beneficial for heavy-duty trucks from a fuel efficiency perspective, or is it, or just from how many miles I can drive if we go to pure EVs? Because your technology is not limited to diesel or gasoline, it's transportation, period. Or do you see it more beneficial for passenger vehicles? So R&D, what do you see more, and where do you see more benefits?
A very interesting question. So we, as I mentioned, we work on not only on the the production vehicle side to serve those, but also on these pilot studies. We have one project that's in Dallas region, and that's exactly what we're doing, is to trying to optimize the freight traffic of the truck.
Freight, okay.
Yeah. And then also you mentioned one point is how we can call the city to make a green light for ourselves. So that's and in fact, that's what we're trying to do, to give these fleet, the commercial fleet, the priority treatment at these traffic signals.
Okay.
So we have this technology for the, especially for the transit vehicles.
Yeah.
That's how the city manage that. When the transit vehicle come to the intersection, we'll give it either early green, meaning that we terminate the phases from other approaches a little early. So give our transit vehicle a little green time.
Sure.
Or now we're coming to the green end. We want to give this vehicle a extended green. So these are two primary priority treatment.
Okay.
We want to use that for the fleet, for the commercial trucks.
Okay.
And we all know that every single stop will cost these the heavy trucks a lot of waste on the fuel side.
Time and money, emissions,
Yeah,
absolutely.
Yeah.
Sure.
And this is where this pilot, and certainly that's where the region, the regional commission wants to prove and to help the local fleet to reduce the fuel consumption.
Interesting.
Yeah. So I would say on the mobility side that would most benefit.
Okay.
Yeah.
All right. Very good. Jingtao, thank you very much for your time. Thanks for listening and watching Reimagine Mobility. Thank you, everyone.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.